Hi again, everybody. This is Brian Wink, Vice President of Solutions Architects at Panzura. I've got my favorite pens in my hand, and that means we're doing another lightboard video. This time I've got the sleeves rolled up because we're going to talk tech. Specifically, we're going to talk about what I like to call the secret sauce. Now, there's a lot of technology here, so this is going to be a multi-part series. This is part one in the series, specifically focused on data distribution. Let's back up for a second. If you think about what Panzura does, we are a global cloud-backed file system. So what exactly do we mean when we say that? Well, first of all, global, I mean global. For example, you could have a user over here in New York City. You might have another user over here in London. And you might have a third user over here in Australia. Okay, now we can have as many users as you want in as many locations as you want, but my whiteboard has a finite space, so I'm going to stick with 3 for the purposes of this drawing. Okay, so let's look at it this way. First of all, we're going to start primarily on New York. So this user, as most users do, they like to talk to file systems, so they're going to have a local filer. This is their local Panzura. I'm just going to draw PZ for simplicity here. And we're going to speak those LAN protocols, again, where we're going to put out that file system. That's either SMB for Windows users or NFS for Linux, Unix users. So what does that look like to an end user? Looks like a map drive. We'll just call it a P colon. So for example, you've got your root, you've got another couple little folders under that, some files under that. We've all worked with file systems before. So the other thing to think about is, again, I've said before, Panzura is a cloud-backed file system. So these can be any types of clouds, public or private, I don't care. And just for technicality, we use the word cloud, but really what it is, it's an object store. Now, I'm not going to go into all the ways exactly that we talk to the object store today. We can do that in another video, but it is an object store. It's out there in the cloud, and we speak to it the way it should be spoken to. So let's look at what happens for a second when a user creates a new file. So let's assume this user here in New York wants to create a new file. Well, what they're going to do is they're going to create this file in the file system. Okay, now, Panzura is going to do a couple of things. The first thing we're going to do is we're going to break that file up into blocks. Okay. The next thing we're going to do, and after this, Panzura always works at the block level, the block change level. After this, what we're going to do is we're going to compress those blocks, making the data as small as possible. And finally, what we're going to do is we're going to globally dedupe against any block we've ever seen before. We're going to compare that. Okay, so let's assume that this block here in the middle is redundant. So guess what? I don't need them, right? Now it's on disk, and now it's ready to be packaged for the cloud. So what we do is we put that in a package. We happen to call it a drive file. It's just a cloud object. It's not important what the name is. Then what we're going to do is version it, encrypt it, and we're going to move it to the cloud where we checksum it. Okay? So that comes out there. It ends up in the cloud. But what we actually do before that is we break the data into 2 different parts. Okay? We have our data, which I've drawn there, and then we have the meta for those blocks. And the meta is really small. I realize I drew it in a really small pen. It's probably hard for you to see. It's because it's hard to even do the math on it so small. It's like about 0.5%. Okay, but it is effectively the soul of the file system. It's the most important part. It defines the name of the file, where it exists in the file system, what blocks constitute it, the properties, the attributes. Everything about the file is defined in that metadata, in that 0.5%, except for the data itself. So, and this is where it's very important, and where Panzura starts to differ from a lot of other file systems out there, is that we manage the data and the metadata as 2 distinct parts. So what that means is when we move it to the cloud, we first move the data, we get it to the cloud, we checksum it, we do all these great things, and it's encrypted, it's done properly. And then what we do is we move the meta. And that meta is really little, again, 0.5%. Okay, so now that data is in the cloud. I moved it once from this user in New York. And again, it was compressed and it was deduplicated. So it's a small amount of information as I can possibly move. Now that we've talked about New York and how New York gets the data to the cloud, let's switch gears a little bit. Let's look at London and Australia. Well, you know, London and Australia, they both have users. Those users like to speak to file systems like you and I. So they've both got their Panzura devices. Again, presenting either an SMB or NFS file system. Okay, and what that means is that they're both going to have their own P drives, P:/ and P:/mounted, but these aren't any P:/. This is a global file system. It's a global cloud-backed file system. So what that means is that anywhere a Panzura exists, they're going to see that file system. So specifically, if I can draw it exactly the same, and it started off with 2 files prior to that New York user doing something. Okay, so now what happens is the New York user did his thing. He moved his data here. He moved the data followed by this little tiny nugget of metadata. Well, what these guys are doing out here is constantly looking for metadata updates. And guess what? They're doing this in parallel. Part of the beauty of our solution is we have an intelligent edge. The cloud, its benefit is that it's infinite, it's cheap, and it's durable. Okay? Our benefit is we're going to present that as a fast and friendly file system with all the intelligence to do the compression, the deduplication, the data movement, all of those things efficiently at the edge. So part of what we do is we're going to now move that meta, that 0.5%, we're going to move that out here. So these guys moved 0.5%. Just like that. It's a rounding error in the network traffic. What that does is, remember, the meta has all the data. So what that does, it shows these users that, hey, that file that was created in New York can now be visible here. All I did was move 0.5%. I did these syncs in parallel because my cloud, my object store is stateless. The intelligence out here, I can keep that synchronization out there. So guess what? I compressed the data, I deduped the data, made it as small as possible, broke it into meta and data, moved it to the object store once. From that one time moving it out of New York, any other location in the world, in this example 2, you could have 2,000 locations. They can all simultaneously, if they want, pull that meta, pull that 0.5% out, and guess what they get from that? They get knowledge of that file. So if this guy in London does a directory listing, he sees that file, just like the user in New York did. But he only moved 0.5%. Same thing would happen in Australia. Same thing would happen in Zimbabwe and Egypt and South America and Brazil, wherever it is you want. The same thing would happen. But now let's look at it. Now let's assume this user in London actually needs to use that data. Well, the first thing that's going to happen is we've got our local cache here. If it's in cache, we're going to serve it out of cache. But if it's not in cache, and this happens, this guy updated something new, there's a couple components that might not be in cache. What we're going to do is we're going to look for the blocks that need to be moved. We don't move files, we move blocks that are necessary. So we effectively dedupe at all times. We're going to pull a few blocks out of cache that were needed. We're going to move the one block out of the cloud that's needed. We're going to move that in parallel very efficiently, completely filling the pipe. That allows that file to completely be there, to be read by that user. And all we moved was the necessary data. We did not attempt to move everything. We did not attempt to move any amount of data to a location that didn't need it. Notice Australia, that guy didn't care about the file. We didn't bother moving it to him. Very, very efficient on the wire. So I've got some other videos to answer some other questions about maybe, what about locking? What if 2 people try to do the same thing at the same time? We're definitely going to talk about that. It's just going to be in the next one in the series. So with that, thank you very much. This has been Brian Wink for Panzura talking about secret sauce data distribution.